from, excuse me, 1B. Oh, all right. So Paul, let me ask you this. All right, let me do something weird here. How would you do this problem right here? Oh, let me see something. Oh, I thought I missed something. Are you with me out there, Paul? Where'd it go? Here it is. Okay. We put this by itself. Boop. Come on. There you go. All right, let me try this again. This problem right here. Do you know how you would do this problem here? Somehow it does relate to your question, okay? And do I have the right person? Who was asking me? Yeah, Paul. I know this is not the midterm. I know this is not the question you're asking about, right? Yeah, well, no, almost, but that won't do anything for you. You don't want to multiply by 1 minus the square root of 5. You want to multiply by something where the middle terms will cancel. So you want to multiply by something that's the difference of squares pair. So you would want to multiply by 1 plus the square root of 5. Right? Because then when you FOIL, the middle terms cancel, no more square root left. Does it make sense? Now, what is I? What is I? What do I be? The question of the ages. All right, be a lot more specific. What exactly is I equal to? No, if I was 1, why would it be imaginary? 1 is not imaginary. That's really weird. That's getting very existential. So when I'm by myself, I am my own imaginary friend. Don't take me down that road right now. All right, I can't go there. 1 is definitely not imaginary. It's a real thing, right? I is imaginary. What? So somebody help us out. What is I defined to be? Does nobody remember? What is I defined to be? Why is it imaginary? How is I defined? All right. What all right, let's try this. What is I squared? What is I times I? Does anyone know?
-1.
Okay, if I squared is -1, what is I?
Rad, -1.
There you go. That's why I is imaginary, because square root of -1 is definitely not a real number. It does not exist on the real number line, which is why it's its own number line that runs perpendicular to the real number line. Now, the real question that Paul had was not about this problem. It was about a problem on the midterm that actually looked like this. So his real problem is a question like something like, I don't know, it's not this, but it looks sort of like this, right? So that's why I brought this up. So we know we multiply top and bottom of this by 1 plus square root of 5, right? So the same idea goes here. What would you multiply top and bottom of this by? This is 1 minus rad 5. We multiply that by 1 plus rad 5. That's 4 plus I. We multiply by 4 minus, no, come on, I. There we go. All right. Same idea, because I fundamentally is just the square root of something. So if the square root works like this, then a square root works like this. I mean, that's I is the square root of something. Square root of a weird thing, right? It's a weird square root, but I don't care. It's still just a square root. So it works the same way. Are you guys with me on that? Okay. Okay, I like it. So this is how math works. Not everything we learn is its own compartmentalized idea. when we simplify dividing complex numbers, it's not new at all. It's nothing new at all. I is just a square root. It's going to act like any other freaking square root thing. Nothing new. Okay. All right. It's wide open now, guys. I made my plea. I do have a plan in case there's nothing coming in, no questions or something. I do have a bit of a plan. But does anyone have, can you go over number 6? Oh, on the practice final, or what are we looking at? Oh, practice final. Yeah, okay. I think, I think on the quiz that had this sucker on there, didn't I provide you with the formula? I think I'll probably do that again. Right, didn't I do that? So like, if z is r times cosine theta plus I sine theta, de Moivre says z to the n will be r to the n cosine n theta plus I sine n theta. And believe it or not, I made you suffer through the proof of that a while back, right? One of the hardest things to do as a math student is to remember things make sense, right? I mean, it looks like if I raise both sides to the nth power, for some reason, n goes inside, but we know better. We went through the proof. It's just the way it kind of works out. It's because of the way that the angle kind of repeats itself as you go through. It kind of just works out. All right. So now, I'll probably, if I give you this kind of problem, I'll probably give you this, just like I did on the quiz. Isn't that what I did? So now all you've got to do is get this into this form. Yeah? No? Maybe? No? Yeah? How the hell do I do that? How do we get that into that form? In fact, I don't even have it in the right form. Hold on. There you go, Jeff. There you go, buddy. What would this look like if I graphed it? What would that look like if I graphed it? What's the x-axis represent here? What's the x-axis actually represent for plotting complex numbers? Oh, no, there's no t here. No, it's no t. What are the parts of a complex number? A complex number is, sorry?
Imaginary.
Yes.
And complex. I mean,
what kind of number is 1?
so that would be x.
What kind of number is 1? As opposed to 2i. 2i is imaginary. 1 is not imaginary. 1 is all right, I see a chat. Let's see. That's an I. Yeah, that's trying to be an I. Sorry. All right, guys, you're going to drive me a little crazy. Before we talked about imaginary numbers, every number we talked about was real, right? Which is why they use the word imaginary, which is a dumb choice, but too bad for us. That stuck, right? I showed you that video that tried to say it should be called lateral, which makes sense because they're kind of to the side of the real numbers, which is kind of a cool idea. All right, so this will be the real axis and this will be the imaginary axis. So where would 1, -2i go? It would be 1 on the real and down 2 on the imaginary. So it's going to be right there. Now, we've done what we're about to do. We've done it several different ways, but The R is just that distance there. How do I get the R? You guys have to know. Isn't there a little triangle there? How do I get the R? Make this bigger. All right. So here's the point. Is everybody cool with that being the point? This is the real, this is the imaginary. This is negative I, negative 2I, this is 1. So that's where the point is. R is this. Isn't there a triangle there? So what's R? Or let's say R squared. What's R squared? Good old triangle shit, right? Yes. Don't we know R squared equals X squared plus Y squared in another context? Imaginary number graphing is sort of like a precursor to polar graphing, right? You have R and theta. So I don't know if that's confusing or if that's better, because you get to do the same kind of math over and over, but it represents different things based on what kind of problem you're looking at. So it's the same way to do this because it's just a triangle. It's still just a triangle. Or a little triangle, little right triangle. It can't escape Pythagorean, right? All right. So what's X and Y in this case?
So X would be 1. And
Yes.
Y would be negative 2Y.
Well, negative 2. Sorry.
Yeah.
Yeah. We just talked about the coefficients. So it's like the A and the B. Remember A plus BI? Okay. So now you just go R squared equals 1 plus 4. So R equals the square root of 5. Is that cool? R is the square root of 5. Now how do I figure out theta? So I need to figure out this angle. Or this, doesn't matter.
Cosine of 1 and then plus I sine of negative 2.
Oh, definitely not. Why would 1 and negative 2? All right, for one thing, are these different? Do they use different symbols? Can those be different?
No.
No. For another thing, why would 1 and negative 2 be angles? There's the angle that this thing makes, and it's related to 1 and negative 2, but it's not equal to 1 and negative 2.
Oh, that would be 315 angle.
Are you guessing because of what it looks like I drew?
Oh, no.
I draw horrible, right? So
I see.
nothing I draw is to scale. How do I officially find the angle? We know this.
Inverse of tangent.
Yes, inverse tangent of
negative 2 over 1.
beautiful, the y piece over the x piece, right? Tangent's y over x. I like it. Okay, and that's a gross thing. If you plug it in your calculator, doesn't that come out gross? What do you guys get? Can somebody do that for me? It's okay to be in degrees if you want to be in degrees. That's fine.
Negative 63.4.
Yeah. So what I would highly recommend is, let me see, where am I at? Oh, I think I did this in the video too, is I would just leave this, or you can even call this, you can call it theta. Why not? Just leave it as theta, but I know what it is. All right. Right? I've defined what theta is, correct? So it's fine if I just say this is theta, because I know what it is. Okay, now, that was the prep work. Now we can actually do it. Now I want to take this and I want to raise it to the third power, correct? Because this equals this if theta is this. All right, I really want you to understand what we did. All I did was rewrite 1 minus 2i in a different way. So now I just have to cube it. And we have what happens when I cube a complex number written in that form. It'll be the square root of 5 cubed cosine, get out of there, theta. Cosine of 3 theta. I do want to erase, there we go. Plus I sine of 3 theta. And then if I were you, I would just plug all that shit in the calculator. Right? You know what theta is, right? All right, where's the chat happening? Okay, all right, I like it. You'll have to take my word for it. Somebody just private chatted that makes sense. That's my favorite phrase. The one little thing about this problem that's a little weird is I didn't give you an angle that you know the inverse tangent of. All right, just use your calculator. Now, if you use whatever it was, -60, whatever degrees, is that what you said? You're not going to quite get the right answer because you have rounded that. Your answer is going to come out worse than it has to. So in your calculator, you're going to want to put square root of 5 cubed times cosine of 3 times this. And then you want to put square root of 5 cubed times sine of 3 times this. And that'll tell you what A is and what B is for the answer. I don't know, is somebody out there still lost with this? Are you guys okay? Do you want to see that happen? Do you go, does somebody need more on that one? If I could just read minds, my job would be so easy. Okay. No, thank you, somebody says. All right. And nobody else is speaking up. So, okay, so I won't show you how that works in the calculator. No worries.
I was working, where do we get I again?
Where do we get it? What do you mean?
You know, you said we put it in a calculator. I mean, the last one, like square root of 5 cube, and then the other one. Like, you know, cosine of 3 theta plus I sine.
So if you had to do, all right, let me think. If you had to do this 6.7 times 4.3 plus 2.56x, right? And you're like, I don't want to do this by hand. So you're going to do 6.7 times 4.3 in your calculator, correct?
Mm-hmm.
And then would you do 6.7 times 2.56x in your calculator?
No.
No, you would do 6.7 times 2.56. And then you know you're going to stick an x next to it, right?
Yes.
Okay, cool. Same thing. I don't need to put this in my calculator because I know it's just going to be, I just want to know what number is going to sit in front of it. I just got to do square root of 5 cubed times sine of 3 times this thing over here. So I can figure out what number goes in front of I.
Okay, and then solve it for x. Or no, or just
Maybe I should show you. Hold on. All right, let me see. Let me see. Get that out of here. How do I get out of there? I don't know. There we go. So I would do, what mode am I in? Degrees. Is that good? No. It doesn't matter. It really doesn't matter. All right. So if I do the square root of 5 cubed, oh no, I got to get out of there, times cosine of 3 times inverse tangent of, was it -2, right?
yeah, -2 over
Right.
1.
I get -11. Sorry?
Yeah, that's right.
Yeah. And now watch this. If I hit second enter, I can go back and just make this sign. See that?
Yeah.
So now I know it's -11 plus 2i. I don't know if that's the right answer. I can't remember what the right answer was.
Okay.
No? Yes? Is that all right? So this is the one that's going to have an I on it. I don't have to put it in the calculator because I just need the number that's going to sit in front of I. Yeah.
Okay, that makes sense.
All right, I like it. Did I miss any questions here? I want to talk about something in general real quick. All right, well, let me know if you have a question. I don't know what you might have missed. So let's do this. I was almost going to create a little thing for you, but let me show you something. So if I were you, one way I would try to review for this is to come here to like the beginning of a section, right? Chapter 4, beginning of a chapter. And then you say, okay, linear functions. Okay, that's easy, right? Slope, y-intercept. Are you guys with me? Linear functions. Check. I know linear functions. Modeling with linear functions. What the shit is that? So if you click on that, you'll very quickly discover that's basically word problems. And word problems with lines. Remember these kind of problems here? Am I sharing the right screen with you guys? Do you see the problem about the town growing? Town growing? Yes, okay, thank you. Does that sound familiar? You remember those kind of problems? You should be in a place where you're like, please, dear God, Jeff, give me a bunch of these, will you please? Give me a bunch of these, please, dear God, Jeff. Yes, well, I'm not going to, but good. So this kind of problem should be quick and easy. You do it, little layup. I like to tell people, scan through a whole test, find a layup, find a problem you feel really comfortable with, and do it. Does anyone play basketball? No? Nobody plays basketball, really? Wow, okay. Does anyone play any sports? No? You're like, either you don't, or you're like, I don't want this guy to know anything about me. Screw this guy. Oh, you did? All right, now let me tell you something about basketball, okay? You go out to warm up in basketball, and what do you do to warm up? You do some layups. You do some little tiny shots. Why do you do that? To get in the rhythm, to get the feel, to build some confidence. So when you see a test, you find those kind of problems. If I have a problem like this, that should probably be one of your layup problems. You're like, let me do that real quick, build up some confidence, get my brain in the math mode. Anyway, all right. So that's a little useful tip, hopefully useful. I don't know. So let's see, keep on with this idea. So if you go to 5 and I go to this introduction part, and then I say, okay, quadratic functions, vertices and all that kind of business, right? And soccer, okay, soccer. But real quick, if you're about to play a soccer game and you come out and you haven't touched a soccer ball in a while, what's the very first thing you do to kind of warm up? Just out of curiosity. Anything? Do you do anything to warm up? Besides like run around just to get your breath going. All right, I'm run. Okay. But then what do you do with the ball? Do you do anything with the ball? Do you like kick the ball back and forth to somebody else? Do you like pop it up and down on your knee, shoot the goal, right? Yeah, exactly. I don't know. Just something to get yourself, something to get yourself in the right physical frame of mind to be in the game, right? Like you reconnect with, anyway, that's enough, Jeff. I think you guys get the analogy, hopefully. You want to warm up. You want to get a warm up problem. Power functions that leads into polynomial functions. This is where we did, we first learned synthetic division, right? I think everybody's pretty cool with synthetic division, if I remember correctly. Finding the zeros of polynomial functions. This is where we wrote the possible zeros, and then we had to synthetically divide to see what works. This is also where I talked about lower bound and upper bound for zeros. Remember those things? All right. And this is where we talked about multiplicities. Is this all coming back? I mean, we did quite a bit of these kind of problems, so I would hope you could kind of tear into this. I would give you a polynomial, you have to factor it, you might have to use synthetic division. You figure out the multiplicity of the roots, that tells you if it's going to bounce or touch, or go through, right? Does this all sound familiar? So, okay. See, this is what, if I were you, and I've kind of like looked at the practice final, and I've done some of it or most of it or all of it or whatever. I'm like, I'm not sure what to do. Run through each chapter and just get a sense of how comfortable you are with the topic. If you're like, I forgot what the shit this is about, then go to the section real quick and just sort of at least look this over. Right? You remember, oh, everybody loved Descartes' rule of signs. You're like, whatever, Descartes. Why couldn't you just leave it alone? Too bad he didn't. All right. Anyway, I think you guys might get the idea. So go to the intro, you look at this, and you're like, okay, so here's exponents, here's logarithms, right? Logarithms, everybody should be pretty good with logarithms, I would hope. We did a little bit of work with log properties recently, right? There were some questions about log properties. What the hell? I never noticed that. Matasaurus? I have no idea. Okay. Then we get into trigonometry, good old trigonometry. And then, of course, we get really recent stuff. We get matrices. We get partial fractions. Ooh, yeah, baby. Some partial fractions. All right. So I don't know. That's if you're kind of struggling with how to study for this final, that is something you should do. Just got to go through a list of topics and make sure how comfortable you feel about it. If you're like, I can't remember everything about that, well, then go to that section and just kind of look at the top at least. It kind of previews all the main things. No? Yes? Maybe? Okay. Any more specific questions? Were there any other problems that I didn't really do in the solution video that we need to do? You guys remember how to do this kind of problem? See how many question marks can I make before somebody says something? Do you guys remember how to do this problem or no? Could use a refresh. Okay. All right. So real quick. All right, hold on. There's chats coming in. Make a triangle. I like it because what does it mean? So if tangent theta equaled 3/7, could you draw a triangle? Could you label the correct sides of the triangle related to that? Okay. Yes. Okay. So where would 3 go? X side, Y side, hypotenuse.
X side.
What did I do X side, Y side? So Y side,
Like-
X.
Like opposite is going opposite, like.
Yeah, the Y side, correct? Is everybody cool?
Yeah,
You guys
Y
understand
side.
this is the Y side because that's going up and down. So that's going to be the Y side. So it's Y over X. All right, cool. So now watch. Can't I take the inverse tangent of both sides? If I really wanted to? Of course I could. So wouldn't this mean angle equals inverse tangent of 3/7? So if I see inverse tangent of 3/7, I can draw that triangle. So now what do I see down here related to what we just did? Do you see an inverse trig function? So I can set up a triangle. So if I call this theta, if I call this angle theta, is that a ratio inside of that inverse trig at the moment? Right, this was a ratio, wasn't it? It makes sense because trig functions are ratios of sides of a triangle. Is that currently a ratio in here?
Yes.
okay, I will accept that answer. How would you make it more explicitly a ratio if your answer is yes, it's not explicitly a ratio?
Over 1.
Yes, put it over 1. Kick ass. So now where would y plus 1 go?
Y side.
On the y side, of course, because tangent's y over x. So that's y plus 1, and that's 1. And now it's just all it's saying is what's the cosine of this angle that you set the triangle up for? How do I figure out the cosine of that angle? What am I missing? Yes, the hypotenuse, that's all. I just got to figure out what the hypotenuse is, and then the cosine will be this over the hypotenuse, right? Do you guys remember that? So if I have a trig function of some inverse trig functions, I need to set up triangles now. So what would this, how would I finish this one out? And then we'll look at part D. Looks good, okay. So what's the, how do I figure out the hypotenuse? Hypotenuse. 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 Yes, okay. So square root of y plus 1 squared, which is y squared plus 2y plus 1 squared, so plus 2. Is that cool? So you do y plus 1 squared plus 1 squared. And that becomes that business, right? So then the cosine of that angle will be 1 over square root of y squared plus 2y plus 2, which technically you should multiply top and bottom by that, so you rationalize it. But if you didn't do that, I probably wouldn't take points off. Okay. Now, how is D the same but different? Why is not? I think you would agree that this is both worse and better. It's better because don't I have numbers in here? Isn't that kind of nice when we have numbers instead of letters? Even for our level, it's nice when we have numbers instead of letters. But why is it obviously worse? Why is this worse than this? More to do, yeah, because I have more than one angle in this damn thing. Damn. So I don't have a trig function of an inverse trig, do I? I've got a trig function of the difference of two. Oh shit. Now tell me what physically does this represent? The inverse cosine of 3/5. What does that represent physically? I love that question because I always think, is somebody going to say like a rock? No. So is it like a point? Is it a ray? Is it a parabola? Is it length of the side? Sorry?
Angle.
Angle. Of course it's an angle, right? This is an angle. This is some other angle. Let's just call it A and B. Let me not call it theta. So don't I have sine of angle minus another angle? Do we have some way of taking care of that? Do we have some way of breaking that up? If only we had an identity. Okay, no one is. All right. Is there an identity for the sine of the difference of two angles? Remember, sine's the nice guy. He's not the asshole.
Sine A, cosine B.
Yeah, we each get a turn, cosine. Let's each take a turn, cosine. That's good old nice guy sine. And it's like, oh, you got a minus? Okay, I'll keep the minus. And then I get a turn with B and you get a turn with A. And everybody's happy. That's sine. Cosine's the asshole. Right? Cosine, if it was cosine, it would be me first, cosine, cosine. You got a minus, screw you, I'll make it a plus. You know, so I really don't know if you guys appreciate that take. And I almost don't care because it's mine. I just share it with you. If you hate it, I don't give a shit. I love it. Good old asshole cosine helps me remember this stuff. How's this going to help us though? Well, now I know that if I draw this triangle, I'll be able to do this and this. Yes? No? And if I draw this triangle, I'll be able to do this and this. And then I can just throw all that shit in the right place. I can just throw it in there. That's the part you guys still don't trust. I have the main thing I'm working with, and then I have information in parts. So I work on the parts and then I throw them back in to the main thing I'm working with. That's how a ton of math works best. It's the easy way to make math. Work on it in parts. You guys still don't trust me. Oh, I guess. I don't know what's happening out there. Can we draw the triangle for A? Can we draw this triangle? Yes, okay, I like that. Yes, we can, Jeff. All right. So where does 3 go? Where does 5 go? Yeah, I will draw 2 triangles. I'm just focusing on A right now. Okay. 3 is X. 3 is X. And 5 is H. Okay, I like it. Now, not surprisingly, don't I know what cosine is? Of course I know what cosine is. Cosine is 3/5. So this is 3/5. I knew that from the beginning. Is everybody with me? If you don't trust me, you can see the triangle. Cosine is 3/5. Now, how do I figure out sine of A? Well, what's this side? Do you guys remember the 3 what 5? 3 what 5 triangle? The 3 what 5? You shouldn't have to do any. Sorry?
4.
4. 3, 4, 5 triangle. So what's the sine of A? Four over 5. Yes, thank you. So sine A is 4 over 5. Do you see how we're putting this thing together? Now I just got to figure out angle B stuff. Do you guys see that? No. So I have the overall question, but the stuff I have to work with is in parts. So let me work with the stuff in parts and then throw it in to the main question. So I've got triangle A figured out. Now I got to figure out triangle B, and then I can do shit. And then I can do stuff. Maybe. So what's triangle B look like? So this is 4 over 1, right? What's cosecant? Where does 4 go and where does 1 go? If you don't like this, you can make this inverse sine, right? Because this isn't cosecant 1 over sine. So what would this be equivalent to? Inverse sine of what?
1 over 4.
1 over 4. Does that make sense? If you don't like cosecant, you can always change it to sine. You just flip the ratio. So this will be 1, this will be 4. So now I know what sine of B is, don't I? Now I know sine of B is 1/4. All I need is cosine of B. Now this one's not going to be as easy as the first one because I don't have a 1 something 4 triangle. This is going to be gross, too bad. So it'll be square root of 4 squared minus 1 squared. So it'll be square root of 15. So the cosine is going to be square root of 15 over 4. And then you can see how the 4's cancel, and you can see over here, you can just put these together, blah, blah, blah. I mean, after that, it's easy. So many things work like that. I have a main question, but it's kind of like involving parts. Okay, let me work on each part and then throw the stuff I get back into the right place. It's the people that try to do everything at once that go a little insane. You can't do everything at once all the time. And just in case somebody out there doesn't realize this, doesn't know this, there's a whole video of a lot of the solutions to this. But somebody reminded me that the semester I made that video, we had done some of the problems in class that semester. So if there are any other problems I didn't really do on that video, you gotta let me know. Or, so how did I know? So somehow I knew that that was a good one to ask you about. Anything else, guys? There were some that were done already, sure.
I have a quick question. You know, you wrote a rad 15/4. Isn't it that has to be like 17? Rad 17/4?
Definitely not.
4 times 4, so 4 square would be 16.
That's right.
And then what, 1 square, that would be 1. So
That's right.
16 plus 1.
No, why are you adding? Why are you adding? Isn't it a squared plus b squared equals c squared? Isn't
Oh, okay, I see.
yeah, so if you know the hypotenuse, you're going to end up subtracting. If you don't know the hypotenuse, you're going to end up adding.
Oh, okay, I see.
Good, good. You got to be real careful about that. It's not always addition. Yeah. Depends on which side you know. Okay. It's up to you guys now. Tell me, are there any that I didn't? Oh, I don't know. Has anybody tried these out?
Not really. Can we go over?
Sure, of course. It's like why I'm here. Oh, let's see. Oh, okay. Well, okay. Even more reason for us to do it right now. Okay. Do you guys agree with me that 18 is relatively easy? Don't you like how I'm careful? I say relatively easy, or no, you guys don't like that. How would you find out? So I know that A1 is 3. How would you figure out A2? What's the value of n the minute I write down A sub 2? Yeah, so isn't this a formula for an? So if I want to know A2, isn't N2? Yes, isn't N2 then? You guys with me? If I want to know A2, then N is 2. Please let that be. Okay. So then 3 times A sub 2 minus 1. So 3 times A1 minus 4 times 2. Is everybody cool with what I just did? Because I know N is 2 for that. And what is A1? What's A1?
3.
Steak sauce, Jeff. Yeah, oh, it's 3. So 3 times 3 minus 8, so I get 1. Is that cool? So do you see why I had to tell you this? Because the next term is related to the term before it. So I had to have a beginning spot. So what about A3? What's N now? What's N now if I write A3? And it's 3. It's crazy, right? Crazy sauce. So then I get 3. So again, all I'm doing, it wants the first 5 terms, right? So I know the first term is 3. Second term is built like this. The third term is built like this. Okay, so it's 3 times A sub 3 minus 1, A sub 2 minus 4 times 3. So what is A2? What is A2?
1.
1, we just figured it out. Yeah, so 3 times 1 minus 12. So I get negative 9. I like it. Let me see if I can make some more room here. This is not very useful down here. Yeah, go away. Oh, my kingdom for a bigger eraser. All right, go away, go away, go away, go away. Just go away, just go away, just go away. Go away, go away, go away. Sorry, guys, hold on. All right, jeebus. All right, so what about A4? It'll be 3 times A3 minus 4 times 4. At this point, you should see the pattern right here. And what's A3? We got A3 to be -9. So this is 3 times -9 minus 16. -27 minus 16 is -43. You guys with me? Nothing amazing there. It's just like function notation. It really is. You're just plugging n in. So just to finish this out, A5 will be 3 times A4 minus 4 times 5. It'll be 3 times -43 minus 20. What is that? -149, I think. You guys can double check me. Okay. So it needs to be relatively easy if I give you the equation for an, because then it's just plugging shit in. It's just plugging stuff in. What's n? Well, n is equal to whatever term you're on. If I'm on the second term, n is 2. That's awesome. 19 is the one that's harder because, especially because I've got fractions. So what probably happened in the process here? What's probably going on with some of these fractions that I told you about? It's a little evil because the fractions have been possibly reduced. It's possible they've been reduced. So I want you, all right, let me see. How can I, does anyone see anything about 19 at all? Does anyone see anything useful about 19? All right, let's see. I know it's a really vague. What about the denominators? What about the denominators? Three plus 1 is 4 reduced to 3 plus 1 is 4. I don't know what that means. 3 plus 1 is 4 reduced to. I don't know what that means. So look here. All right. Now look, here's what I notice. Do you see how this is 2 and this is 2? Right? Yes? No. Okay. What if I made the top of this 2? What would the bottom become? Yeah. Maybe the bottom grows by 1, but look, stay with me. Yeah, maybe this is supposed to be a 4. See how this is a 3? Maybe this is a 4, and then that's a 5, and then maybe that's a 6, right? Yeah, so if I make, so let's see. Let me leave this one alone for a minute. So I get 2 over 3. If I change the top of this to 2, I got to change the bottom twice. 2 is 4. If I leave this one alone, now what does this next one become if I do the same thing? Make the top 2 so that the bottom becomes 6. Okay, thank you. And what do I have to do the first one now? -1 over 1, so it actually becomes, if we make the top 2, the bottom's got to become 2. So now look, 2, look at that. Do you see that? Am I saying that's going to happen every time? Hell no. This is a playing around thing. This is a, all right, let me try this. Let me see. What if I make all the tops 2? Does something nice happen here? Yes. Always? No. If it didn't lead to anything good, I would try something else, right? Okay. So it looks like the top is always 2, except the sign alternates. Right? So how am I going to write the sequence here? So the top is always 2, except it's always alternating in sign. So I know this has come up a lot, but -1 to the n. You guys agree that -1 to the n will be negative and then positive and then negative and then positive? Do you guys see that? -1 to the first is -1. -1 squared is positive. See how the second term is positive? Every top is 2. That's taken care of. Sign changes. That's taken care of. Now, what's happening on the bottom? The first denominator is 2. The second denominator is 3. The third denominator is 4. So how is it based on n? It can't be just n down here because then the first denominator would be 1. First denominator is supposed to be 2. So what's on the bottom then? Not just n.
+1.
N plus 1. You guys see that? First one, n is 1. 1 plus 1 is 2. Second one, n is 2. 2 plus 1 is 3, and so forth. So a lot of the stuff we learned this semester, a lot of it is understanding where the flexibility is, understanding what you need to look for, understanding what could happen. So when you see a sequence like 2, 3, 4, 5, 6, you're like, thank God, that's easy. But then what does it really mean in terms of n? Well, n is 1, 2, 3, 4. Oh shit, so it should be 1 more than what n is. Kabam. Now, am I done with the problem? No. Now I think, isn't this the section that made extra credit? Summation notation? I think so. Didn't I make that section extra credit? Yes, okay. So I would probably ask a question that I would stop here. Or you guys would, I would say, write the sequence, write what an is, right? But all the summation notation would do is, how many terms am I adding?
5.
5. So I'm going to start from, what does the book use? K? 1 to 5. 2 times -1 to the k over k plus 1. That's what it would look like in summation notation. So I want to add this sequence elements up from the first element to the fifth element. That is what this is. But again, that was extra credit. So I would actually ask a question that would have you stop here. Is everybody with me? I might have a bonus question related to this. I like to give bonus questions on the final that come from the extra credit sections. I just do. Can we do one more example? Sure. Oh, let's see. Let me steal one from the book. If I try to make one up, it's going to get gross, possibly. Here we go. Doobie doobie doo. Doobie doobie. Doobie doobie doo. Let's see. Wait a minute. No, I don't want that one. It doesn't really matter. Well, I mean, yeah, I don't know. Let's see. So I think, didn't I assign like all of, oh geez, I got to change over to the other thing. Hold on. There we go. Didn't I assign 21 through 24 or was it through 23? I can't remember. I can't remember.
You did 21 through 24.
Okay. Did anyone get number 24? Do you think? Does anyone think they got 24 figured out? What's the weirdest term in that sequence? What seems like it's out of place? Or are they all good? What's going on? Oh, all right. No. All right. I really want you to understand. If you just look at one, don't they all look the same? When they all look the same, except one piece is changing, that is the easiest kind of sequence to deal with. Don't I pretty much know it's going to be 1 minus e to something with n over 1 plus e with something with n, right? So look at the pattern. Look at the pattern and go backwards. This is 4 over 5, the powers, right? 3 up here, 4 down there, 2 up here, 3 down there, 1 up here, 2 down there. So what should the one before be? What should be where there's a 0? What should it be? Just using that pattern. You guys with me? What's happening to the top power? It's going 4, 3, 4, 3, 2, 1. Earth be. Oh, sorry. So what should this one be? If this is 4, this is 3, this is 2, this is 1. What should the power here be? If it looks the same.
0.
0, correct? And then what should the power on the bottom be? 1 plus e to the 5, 4, 3, 2, 1, right? What is e to the 0? What is anything to the 0 except
1.
0? 1. And what's 1 minus 1?
0.
Yeah. Are you guys understanding what I'm saying? So that makes complete sense, because that's exactly what it would be if it follows that same pattern. Oh my God. So do you guys understand what I mean over here? This is 1 minus e to the something with n, 1 plus e to the something with n. So the first term, see how the first term has a 1 here, second term has a 2 here, third term has a 3 there. So the nth term has a what here? First term has a 1, second term has a 2, third term has a 3. So the nth term will have a freaking n. I love it. Now, on the top, first term has a 0, the second term has a 1, the third term has a 2. So what's this going to be? It's not n, right? It's not the same. It's always 1. No, not n plus 1. First term has a 0. Second term has a 1. And minus 1. Okay. Do you guys see how that works? Sometimes it's that easy. That's how you, so that's why when I first went over this with you, let's try a different problem out, because that one's almost kind of too easy. If you, now that you see what to look for, this was so nice because they are already all the same. Do you guys see that? They're already all the same. That's what you were like, please be like that sequence. And then I could just pick out what changes. And that's where some n shit goes, because that's the only thing that changes as you go through a sequence. So let's look at the first one. All right, hold on. Let me erase some of this. The first one definitely gets worse, right? That's why I told you guys to do this kind of like in reverse order in the homework, because the first one is actually sort of the hardest one. Let me see. Let me pull this over here. So if you try to do this, how does it change from one term to the next? We kind of hope maybe we keep adding the same thing, but we don't, do we? Nope. Okay, no, we don't. What do I add from here to here? What do I add from 4 to 7? I add 3. I'll answer my own question. Then I add 5. Then I add 7. Then I add 9. That sucks. But there is a sequence that we know works like that. Right? Get out of there. What sequence is this? Don't miss anything, Jeff. What sequence is this? What sequence is this? What sequence? The squares, not the powers, the squares, right? So this would be n squared. That's how I represent it. Is that cool? Does that make sense? The first term is 1 squared. The second term is 2 squared. Yes? So what if I had a sequence that looked like this? Isn't that almost n squared? But aren't they all just, they're not n squared, are they? They're n squared. Come on. It's not just n squared. 1 squared is not 2. 2 squared is not 5. But 1 squared plus 1 is 2, and 2 squared plus 1. So this would be n squared plus 1. Do you guys see where I'm going with this? What if I add 2 to everything? Isn't this 4, 7, 12, 19, 28? Does that look familiar? Yeah, this is n squared plus, well, be careful. This is n squared plus 3. See that? Because this is already plus 1, and then I added another 2. Now, if you're paying attention at all, I just did that problem for you, right? Well, with your help. Right? Number 21, you have the answer to. Do you guys see that? So if you can't see, like 22 is very much related to what we had to do with 21. It's, if you just can't see what the hell, then you try to add or subtract something from all the elements, right? All right, let's see. Oh yeah, thanks. Yeah, you're welcome. All right. What else you guys want to look at? You're like, I don't want to look at anything, Jeff. What do you feel the need to look at, or so let me, well, nobody's asking anything. This weekend, I'm going to work on catching up on corrections to midterm, corrections to quizzes, so that I get your grade more solidified. So that when we meet again for the final, you'll have a better idea of the target grade on your final in order to pass or make a B or make an A, right? Can you do question 10, A, B, and C on the practice final? Okay. Oh, all right. So let's see. Looks like I was already doing something here. Let's see. Let's get rid of all this stuff here. You're gonna need a bigger eraser. I know I need a bigger eraser. All right. Yeah. All right. Something like this needs to be easy. If it was log base 3 of 27, what's the answer? The answer to a log is always a what? What's the question that the log asks you? You know, like, I think that makes as much sense. Does anyone remember? Like, all right, so when I taught you guys this, I said, okay, what's the square root of 9? And everybody went 3. And I said, cool. Why is that so easy? Because you know what the square root symbol represents. You know what question it represents. It says, what does it take 2 of to multiply to be 9? That's the question it represents. Oh, I see. You're answering this question. So this would be the power. So what does a log ask you? What power does the base need to become the inside? So this would be 3. And then here, how would I flip it? Well, like Austin said, I would make it negative. Wouldn't that flip the answer? So I want you to realize something. So what, somebody tell me, what is log base 2 of 16? Now that you know what the question is. What's log base 2 of 16? How many 2's multiply to be 16? 4. I like it. So what is log base 2 of 1/16? Negative freaking 4, of course, because what do you do? What kind of power makes something flip from what it would normally be? A negative power. So if 4 on 2 makes 16, negative 4 on 2 makes 1/16, because a negative power means flip. So if you just remember, the answer to a log is a power. That drives you through how you think about getting the answer. What power would make what needs to happen to make this become this other thing? Okay. Then we have the next level of logarithms, which is logarithmic properties, right? What could I do with this 2? I'll tell you what you could do with that 2. Hey, what could you do with that 2? What does a logarithm allow me to do with a coefficient? Where'd that 2 come from? Where could I put that 2 back? Move it to the exponent. I like it. So it goes up here. So now I got natural log of x minus 1 squared minus natural log of x squared minus 1 plus natural log of x. Now, so now I could apply other properties. What do I do when I subtract 2 like base logs? What do I do when the difference of 2 logs? How can I rewrite that? Okay. So remember, the difference of 2 logs is the log of the quotient. And this is plus this, so that's going to be times, right? That kind of makes sense. It's kind of nice. When I subtract logs, it becomes the log of the quotient. When I add logs, it becomes the log of the product. That's a beautiful analogy. And now all I have to do, what could I do inside here to simplify this? Anybody? Is there any piece of that I can simplify? I can't do shit with the top. Well, I'm saying
X plus 1 times x minus 1.
yeah, you can factor the bottom, so then one of these x minus 1s die. So then I end up with natural log of x minus 1 times x over x plus 1. Shaboo! Now, if this 2 wasn't here, right? If this 2 wasn't here, is this an easy problem?
No.
The answer is yes. If that 2 wasn't there, what does the 7 and the log base 7 do with each other?
Cancel.
They cancel because it's 7 to the, and what's the opposite of, what's the inverse of 7 to the something? Log base 7. So of course they kill each other. Just like a cube root and a cube kill each other. Inverse functions kill each other. That's what they want to do. Unfortunately for us, the damn 2 is there. Damn 2. If only I had a way to get rid of that 2, and then I could do just like we said. Oh man, I can be a dork. Sorry. Is there a way to get rid of that 2? I got to get it out the way. Move to another state. Oh, move it to the exponent. Okay. So move that up there. So now I got 7 to the log base 7 of x squared. And then these 2 can finally kill each other like they want to. And my answer is x squared. Kabam. Kabam. Okay. Let's see, that was the last question I had. Any more things that you guys want to look at? Get out the way.
So the final is on June 4th, right?
Let me show you. That does not sound right. Look what I've done for everybody. I have not Yeah, I don't know if you said June 4th, you're off by quite a bit. So June 1st. So here's my office hours on Tuesday, and then here's when the final exam is happening.
Gotcha.
Cool. So I will be adding the Zoom links in over the weekend or sooner out it, whenever I think about doing it. Is that cool? And just to remind you guys, I do have office hours for all of my students. So that includes you guys, obviously, earlier that day, right? 1 p.m. to 2:30. And then our office hours before our final starts at 4:45, right? So that's the time to come and just with your last minute questions about whatever.
So there will be 20 questions on final exam.
Why do you say that?
So was that
Why do you say that?
just to know?
I love it when people ask. Anyway, sorry. I just like that you picked a number hoping that I would go with it. No, there'll be, normally my finals are like 24, 26 questions. And when I say that, I'm counting all the A, B, C, D, E, F, G parts, right? Because I always hate it when a teacher's like, there's only 4 questions and they're all A through J. I'm like, do you know how to count? No, actually, no. Every correction is due the day of the final. So before you start the final, that's when everything's due. I think I made homeworks and stuff due the 31st just so you would get them done and not be working on homework at the absolute last second, right? But your corrections, like it says, like I've said this semester, the quiz corrections, midterm corrections due the day of the final. Before our. All right, so I'll make it official. We'll go ahead and end class now. Let me know if you need to hang out. Please don't forget, come to the final early to make sure that connection, everything's good. Everything I grade in this class is out of 100. Yeah, I'm good with math, so I don't do points for things. Normally, if somebody's bad with math, you'll see on their syllabus, midterm is worth 500 points and finals worth 600 points or whatever. That means they're bad at math. I'm good at math. So everything I grade is out of 100. Take care, guys. Anything else?
I have one more question before you go.
Yeah.
Just the same question that we were working on earlier from the eliminating the parameter one.
Yes.
So I solved, I think, for sine.
Oh, look at that. It's still there. I don't know. Can you see it?
Yeah. So
Okay.
the way you solve it, it's still the same way. Like I did like the 4 squared minus x minus 1 squared.
Good. And square root of that, right?
Yeah.
Okay.
And so, I mean, can I tell you what I got to see if I'm along the right path?
We got this, right?
No, I did not get that.
That's what you said to me, isn't it? So you want to know the sign. So you want to figure out this side, and this side would be this, right? Right? It'll be 4 squared minus this squared.
How
There's no-
come you wouldn't further?
Huh?
How come you wouldn't further simplify the?
No, I definitely will. I didn't want to do that until I knew you were here.
Okay.
Yeah, but then you can simplify the inside. Well, that would be minus, was supposed to be 15 minus x squared plus 2x, I think.
Okay.
Yeah,
Okay.
so you can simplify this. You can reduce one of these. You can pull this out front. I mean, there's a few little tiny things you could do. Sure. I like it.
Okay. Okay. I got there, which is good.
Would you agree with me that that's a funky looking thing?
Yeah.
And of course it is, because the freaking picture looked like, isn't this the one that where it looked like that or something?
Oh yeah.
So we just know y as a function of x is going to be a weird thing because that's a weird graph.
Definitely. Yeah. Okay. Yeah. I really struggled with this one. That's why.
And to be honest, there actually should be a plus or minus on it, but it's not that big of a deal.
Okay. All right. Thank you, Professor.
Okay. How's everybody else?
I had a quick question regarding when you were drawing the triangle with 1, 2, and rad 5 as a hypotenuse. Now, when you're trying to get that angle, right, for theta, can you also get that with law of sines or law of cosines?
Do you remember, was it one of the problems on the, where was that from? Was that just a problem I made up or something? I remember that square root of 5. What was that? Was that a problem in the book?
It may.
Darn it.
No, wait, I think it was number 6 on the practice final. I think that's what we were using.
Oh, yeah, there it is. Okay, let's see. So you're, all right, so what are you?
So let's say, so we know that, you know, since it's a right triangle, you have 90 degrees for C. The hypotenuse is rad 5. Right.
Sure.
So law of sine says sine 90 over rad 5 would be equal to sine theta over 2. Right.
All right, let me see. Wait, let me catch up to you. Oh yeah, so this is 2. Oh, sure. Yeah, sine 90 over the hypotenuse, sure, would equal sine theta over 2. Sure, okay.
And then you multiply 2 by whatever number that is. And then you would do.
I want you to realize something. So you're asking me if you could do this instead of inverse tangent.
Yep. Yeah.
I really want you to realize you don't need law of sines. It's a right triangle. What's the sine of theta? Would it be 2 over rad 5?
Yes.
All right, so I don't need law of sines. It's a right triangle.
Okay.
But you just kind of proved that the law of sines is a generalization that becomes normal trig if you give it a right triangle to work with, right?
Okay.
So your approach is fine. There's really nothing special about picking tangent. Y over x is the way to do it. We just do this because then it's based on the numbers I knew from the beginning. It's not based on anything I had to create myself.
Okay. I
So
just
yeah,
wanted
you're completely
like,
correct. Huh?
That's immediately where my mind went to for some reason was law
No,
of
it's
sine.
fine. That's awesome. There's nothing wrong with that. It helps you. And then when you see the connection between law signs and just regular trig, then yeah, then you can start to realize I don't have to go to law signs if I have a right triangle. I only have to bring it up if I don't have a right triangle. But it's good to be reminded that they're really the same thing. Just one is a more specific use. Yeah.
Got it.
Yeah, you could always do that, dude, to figure out the angle. You could always figure out the side you need and then set up something else. You don't have to use tangent. It's just, that's really the only reason we do it, is because then it's directly related to numbers we're given instead of numbers we had to calculate ourselves.
Okay. All righty. Well, thank you.
You're welcome. Ayan, you okay?
Yes, Professor. Just I was listening.
Okay.
All right. Thank you.
See you.
See you.